Hey, good afternoon, everyone. And apologies for the small delay in starting the session. We had some technical difficulties, but more important is probably that I'm here and you can still enjoy the session. So thank you for being here. I hope you already had a pretty good aMS day so far. And I'm going to try to follow the same flow for the pre-last session of the day. And knowing that we started a little bit later, shouldn't block me from going through most of the demos that I want to show you. And you could probably pick up most of the information that I want to share from the demos. And it means that I'm going to skip a couple of slides or at least go a little bit faster. So my name is Peter, based out of Belgium, working for Microsoft as an Azure technical trainer. And I'm going to inspire you or clarify the confusing world of running Azure containers on, or running containers on the Azure platform, where you might be familiar with some acronyms or maybe some container services already. But after talking to so many customers being involved in migrations from on-prem to different Azure containerized workload scenarios, the challenge is obviously deciding like what kind of container runtime should I use for hosting my applications. And that's the main message in the next 45 minutes. We obviously need to thank our sponsors. Without any of these, probably events like this is not even possible. And even in a virtual world, it's still quite important. They provide some nice support. They provide licenses for toolings that we need and so on. So I'm quite sure you heard the same message in all the other previous sessions, but if you know any of them, I would say talk to them, thank them for helping to organize an event like this one and spicing up your technical knowledge. So feel free to reach out, stay in touch. I'm available on Twitter, LinkedIn. I'm not on Instagram, not on Facebook, or at least not too professional on Facebook. And the reason why I'm here is because I like talking about Azure, inspiring customers, partners, and sharing my experiences, sharing knowledge. So with that, let's get started. And what brings you to containers might be a good first question to answer. And what it means is helping you in understanding like where do containers fit in my overall workload migration scenario. So a long time ago, you probably started building your own data center environments and running physical servers. From there, about 15 years back, we moved up to virtual machines running different hypervisors. Could be Microsoft Hyper-V, could be VMware. Xen Server was a big one at some point in time. And moving to cloud is the next wave in your platform architecture, where you could still deploy virtual machines. That's what we call rehosting, because what we're doing there is performing a lift and shift migration from the virtual machine you run on-prem, migrating into, for example, an Azure virtual machine, but you're not really changing anything on the virtual machine side. So the VM will run on Azure in the same way it's been running before on-prem, with a side note that obviously the operating system and characteristics of the VM need to be supported in Azure. If you want to take it one step further towards more cloud native, you could move to serverless, running solutions like Azure Functions, Logic Apps, Service Bus, Event Grid, those kind of scenarios, together with some other microservices. And that's actually the perfect fit for containers. Now, what we're doing with containers is or building new application architecture from scratch, where instead of still relying on virtual machines, you're going to move them into a containerized scenario. But it's not exactly, I would say, as serverless as microservices and the serverless components. So one of the use cases, what I'm going to try and show you in a couple of demos is, for example, migrating a somehow legacy application where you have dependencies on an older .NET framework, in my example, that could run fine on Azure Web Apps, but maybe it's a bit too new. You don't know it yet. You don't trust it yet. Whatever reason could be a good one for not completely moving up to microservices and serverless. So that's the perfect angle. It's not as complete and as management depending as a virtual machine, but it's not as looseless, flexible as the serverless or microservices. So perfectly positioned right in the middle. Now, if you look at what a virtual machine architecture looks like on the left-hand side, you start with the physical machine bare metal deployments. You deploy your host operating system, could be a Windows machine. On top of that, you deploy hypervisor, so the Hyper-V, or you deploy like a VMware ESX machine.
Peter, sorry to interrupt.
And on top of that, you deploy the virtual machine itself. Within each and every virtual machine, you have the operating system, like a full-blown operating system inside the virtual machine. You deploy binaries, libraries, think of .NET, think of Node, Java, those kind of scenarios, and eventually you deploy the application. Would be about the same for database servers, file servers. That's the topology we've been using for so long. We're now moving to containers. The underlying architecture is slightly different, but the functionality, the capabilities we get out of the containerized workload are not really changing. So what it means is we still have some physical server where moving to cloud, you don't really know anything about the physical dependencies, most probably, but nothing blocks you from moving containers from your on-prem environment, from your development station, into an Azure environment, into an AWS environment, Google Cloud environment, or any other hosting provider. And what makes this containerized workload flexible, dynamic, and easy to move around is the Docker standard and the Docker engine. That's providing you something similar like the hypervisor in the virtual machine world, where this time we deploy operating system on top of the physical server. You install the Docker engine or the Docker daemon on Linux or Docker desktop in, for example, a Windows 10 client or macOS. And from there, you still deploy binaries and you're going to containerize your applications. So the nice thing is that a lot of the traditional workloads you have, like web servers, database servers, file servers, workloads that run calculations, those kind of scenarios, are now typically targeted towards the containerized version. So that's a little warm-up, I would say, where most important, the container alphabet soup is trying to highlight what are the different options we have on the Azure platform to run container workloads. So honestly, we have a lot of options available. Starting with the probably most convenient one, or maybe the easiest one to start from, is up here, container instance. Now, what is container instance? It's allowing you to bring your container to Azure. How can you bring your container to Azure? By moving it into container registry, or in short, ACR. Now, you don't need to use the Azure Container Storage location, but I'll talk about it a bit more later on. You could also use containers from other container repositories, where the other option could be Docker Hub. It's like a public, but also available as a private option. Container image storage location, where you literally gonna store your container and from there handing it over to container instance. Or you could use app services.
Peter, do you hear me?
Where most probably you might know app services from Azure.
I don't think he's
as a web service
that's the problem.
Okay.
Where instead of
Very
running
sorry
a full
for that.
virtual
I
machine,
sent many messages, but
you literally gonna
said
bring
at the
in
beginning that
your
you can't hear us.
container,
So.
but leveraging using a lot of the capabilities, the characteristics from app services to host your containers. Out of the specific .network, at least some time ago, you could also use Microsoft Service Fabric. Now, Service Fabric is a long-standing Microsoft product that you could run on-prem, you could run in the cloud for hosting larger, complex .NET applications natively on Service Fabric, and in the meantime, it could also run containers. Kubernetes, AKS, one of the other important scenarios, allowing you to bring the more complex container workload scenarios into an Azure world. And if that's not good enough yet, we have an integration with partner ecosystem where you could deploy virtual machine-based scenarios. Nothing stops you from deploying like a Windows Server 2019, installing Docker inside and using it as a container host. Or for example, Red Hat OpenShift is another scenario where you start from a Red Hat virtual machine topology using Kubernetes flavor inside a VM, and that's becoming your host. Out of Docker, Mesosphere are a couple of other scenarios, but not going to talk too much about them. So a lot of options. So the easy part I would say is, how do you decide, how can you figure out like where to get started? Should I use AKS immediately because everybody's talking about Kubernetes all the time in the container world? Should I start small? Should I start easy and using Azure Container Instance? Now, before all that, you need to become familiar with Docker. So again, what is Docker? It's almost like the standard. It's not just the tooling, it's also the company behind it. And what it did a couple of years ago is really embracing and leveraging on the capabilities of building smaller, literally containerized platform capabilities. From there, you have your underlying infrastructure, physical or virtual, doesn't really matter anymore. And once you have your application and you move it into a container, you can run the container all over the place because, again, we're supporting it on Azure, AWS, on-prem, Windows client, macOS, doesn't matter anymore. Now, it all sounds quite easy, but it could take a while before you're actually pretty proficient, I would say, in managing your Docker environment. The management, it's done using Docker command line. So whenever you install the Docker desktop, Docker daemon, Docker server, depending on the backend platform, you can always interact with your Docker images and later on the Docker running containers using command line interface. So I'm going to switch to the first demo scenario. And what I have is Docker on my machine. So I'm running Windows 10 and I can deploy and run my Docker containers. If all goes fine, there we go. It's providing me some details about the version. I'm typically using one of the pre-builds to just making demos a bit more exciting, but also testing out new capabilities. So when you deploy your Docker desktop on a Windows client, it's also providing Docker Compose that allows you to combine multiple standalone container images into a workable scenario. Think of file system in one container and the web front end in another container, or maybe a lightweight database like Postgres, MySQL in a container, and at the same time using a web front end. And the two containers together, or 5 or 15, doesn't really matter, are building up your application stack. There's also an emulator for Kubernetes, interesting if you want to test from like a development perspective. Now, to validate that everything is running fine, you could run Docker info. That's like a little command to validate what's happening on your machine. So once you get some output here, it's actually telling you that the service is running, and it's also telling you what's happening on your machine. So in my case, I have, along the years when I was running Docker and continuously upgrading, I used 46 containers. None of them are running for now. And those 46 containers are based on 6 images. Now, what is a Docker image? It's an offline version of an application. So it's almost like a VHD file, like an offline disk. And when you hand it over to Hyper-V or a VMDK file, when you hand it over to VMware, you push the startup button. That's where it becomes a virtual machine. So it's from offline to running, images to containers. That's the easy way to describe it. We can validate the Docker images we have. And a Docker image is a layered set of binaries, stripped down kernel. It's not containing the operating system itself because it's literally leveraging on the operating system of the host. And from there, you can start running applications. So let's try, since I'm on a Windows machine, let's do some Linux integration and start up a container, Docker run Ubuntu. It's probably like one of the easiest to start with. But the nice thing, what happens is, again, it depends on a container registry. And I talked about Docker Hub. So what's happening here without doing anything, it's connecting to Docker Hub and downloading the latest version of the image. Now you could make this a bit more advanced and searching for the specific characteristics of Ubuntu client running inside a container, but just for the ease of demos and gaining a little bit of time back, I just wanted to show you like how easy it can be. So I did Docker run, downloading the container, and is it running, is it not running? We don't really know. So we can validate using Docker container list. Show me that nothing's running. Now, why not? The characteristic of a container is that you need to tell the container what to do. And if you don't tell the container to do anything, it's not going to do anything. It's going to start up, trying to start some process. And if there's no process instruction, it's literally stopping again. So we can validate. These are my 46 historical running containers. And the latest one, my Ubuntu environment here, I can see that I started up like 57 seconds ago, and it exited 56 seconds ago. So it actually ran for like 1 second. So we're going to make this a bit more interesting. And we're going to provide an instruction to the Ubuntu container to at least show me something. So this could probably be like /bin/bash. That's the instruction to start like the bash command, or using the -it. And that's telling any container, not just the Ubuntu one, but any container to start up in interactive mode, allowing you to provide some logging information or getting access to the subsystem. So from here, it's Linux, so I need to clear my screen. There we go. And I could do ls. It's going to show me the content of the container, like the file system. I could run top. That's going to show me the running processes, system availability, Control-C, and I'm back in my prompt. From here, I could exit, and I'm closing my container. Where now, if I check back in Docker container list, the container is gone, but this time it ran for a little bit longer. And it's all the way on top. So that's my second instance, ran 51 seconds, and I closed it 11 seconds. Now, the nice thing is also that each and every container instance is a unique instance. What it means, I'm using the same image, but my initial demo was container ID, like almost like a virtual machine name, if you want, D42, and so on. I closed it, I stopped it, kicking off a new one from the same image, but creating a new container, and it's creating a new container ID. So that's another way to manage it. Now, making it a bit more exciting, let's switch to a more fancy application. So it's a .NET app that I built. It's a little e-commerce environment. And hopefully it's going to start up fast enough. So it's a full-blown app. It has all my Visual Studio projects in there. It has the website in there. I'm running some database integration. I'm running some product images. And as you can see here, I'm using appsettings.json. Let me zoom in a little bit. appsettings.json, and that's where I'm connecting to, in this case, a SQL Azure database, but it could be any database. So client server application or front-end, back-end web interface connecting to a database backend. Now from here, imagine that I want to move this into a container. We could make this a bit easy for ourselves, and that's the nice thing about Visual Studio, where you're going to grab the project, right-click, add Docker support. So what this is going to do is producing a technical script file, and let me just fire it up. And it's going to ask me, like, what underlying operating system do you want me to use for hosting that application? Now, interesting enough, I'm on a Windows client, so you could assume that it needs to be Windows. Now, it's .NET Core, where the benefit is out of the .NET Core. It runs on Windows, and it also runs on Linux. And the fun thing is with Docker that I can actually switch between operating systems. So right now, I'm using my Docker desktop engine that's enabled for Linux containers, although my underlying client operating system is Windows. So that's another interesting trick on a full Windows client. What it's going to do from here is recognizing the application information and producing a Docker file. Now, if you're a little bit into developing, you probably know what it takes to compile your app. It means you need, in this case, NuGet packages. You're going to run .NET, .NET build, .NET restore, those kind of steps. And that's literally what we're telling our Docker file as well. Now we bring in a first little piece of magic. It's a pre-built Docker image provided by Microsoft that has the core information for ASP.NET 3.1. The same to going to a virtual machine, installing Windows or Linux, downloading ASP.NET, and it's going to host your application. Where next we tell the container image, start from that baseline, create a folder called /app, and we're going to tell you to start up port 80 and 443. Why? Because it's a web application, right? Once you have that, we're going to inject a second image where we're going to grab the .NET Core SDK, creating a new folder source, and in there, and I have a pretty large application, it's copying literally all the source code from each and every standalone module in my application. Like think of a monolith application, like one big beast of a server, all the modules are running there, and that's building up my e-commerce environment. From there, I'm running .NET Restore. So this is happening inside the container. I'm switching to .NET Build, .NET Publish, creating like a web publish package file. And eventually, quite important, I tell my container, once you start up, I want you to execute .NET, pick up my .NET application, and start up the simple commerce web host. So the e-commerce example, 100% the same as instructing your Visual Studio in like debug mode if you want to pick up that .NET.exe and firing up. From here, you could go through the compile option. So right-click build, and the outcome is a Docker image. To speed up the demo a little bit, I already went through this exercise, and the outcome is technically two different options. It's, oh, that's the wrong one. It's this one. My simple commerce in a dev tag, because it's not production ready yet. I first need to test and validate everything if it's going to work fine. Now from here, I could do Docker run simple commerce, yada, 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 and testing it on my local machine. I'm going to save you from showing that to speed up the demos and the story a little bit. And moving on. From here, we're going to run our container and moving it into an Azure world. So what we're doing is relying on that container registry, where preferably I would say if you run containers on Azure, the recommendation would be to use Azure Container Registry, but it's not exclusive. So if you have the Docker Hub integration, sorry, if you have the Docker Hub integration, you can perfectly integrate with that one. If you use other container registries from on-prem, from AWS, you could also use those as long as the network connectivity and credentials are fine, you're good to go. Now, what is a container registry? It's some kind of storage emulator, if you want, on top of the Azure platform that allows you to store images. So the container registry is not hosting, not running the containers themselves, but it's the landing page to store containers. Like a lot of other services in the platform, you have different flavors, basic, standard, premium. In this case, the recommended option is premium, not because it's more expensive, but it's giving you like enterprise-ready features. Better performance, larger storage capacity, allowing you to store a larger amount of container images, and also allowing you to, for example, run source code scanning. Like if you want to find out if there's any suspicious code or maybe outdated packages or anything else, you could also run through some kind of anti-malware validation scan before actually exposing into a running state. So from within Container Registry, that's our service. We create a repository that's a location for storing one or more container images. And from there, we're going to hand it over to any of the other services I'll talk about later on to actually run the container. So we start from our local machine and moving containers into our container registry. So what it involves is two different steps. You first of all need to make sure that you have your container registry available in Azure. Let's maybe show you that first. So you create a new resource called Container Registry using Portal, using PowerShell, using ARM templates. Doesn't really matter. And it's going to ask you the name. It's going to ask you the location where you want to run it. And that's pretty much it. And by the way, the security integration I talked about is Aqua or Twistlock. Any developer in the audience probably recognizes those tools because they've been around for years, and you could also install them as extensions into VS Code, Visual Studio, and running your code scanning before actually publishing the apps. Where now we're doing the same thing, but targeting the container image instead of targeting your source code. So from here, we have the container registry service up and running. It's waiting for images, and we're going to push an image from our local development station into the container registry. To do that, we need to go through two different steps. The first step is making sure that our container, so this is my starting point, that this container has a reflection of the registry name in the name of the container image. So my registry is called PDT Simple ACR. So the registry, Azure Container Registry for my PDT Simple container. Reflecting the name from one container image into another is using the Docker tag command. So you would do Docker tag name of the source container, simple commerce web host, and so on, with the name of the target container registry / the name of the container you want to use. Once you have that, you can run docker push, and that's the command you need to push your container from on-prem to the registry. Where next we need to use the name of the registry, PDT Simple ACR. It's this, I guess. Worst case, I need to check. I'm not that good in memorizing comments. Let's do a quick check. That's super helpful. Let's do other push options. Nice. Oh, I know what it is. It doesn't want it. I'm not going to bore you with that. It's Docker push with some characteristics that I somehow lost for now. And what it's going to do is forcing you to authenticate. So there's obviously security in place where you need to provide your container registry credentials. You get those when you create a container registry. Next, you run docker push. I was already authenticated to speed it up a little bit. It's going to copy, so almost the other way around than what I showed you with the Ubuntu environment, grabbing it from the Docker hub to your local machine, where now we're going to push it from the local machine into the container registry. The outcome of that is my repository, where I have my Simple Commerce latest version container. So that was literally the container image that I uploaded. Now, taking it one step further is running a container. So now we have a container image running, not running yet, waiting to spin up in Azure, where the first example I'm going to use is container instance. Now, what is container instance? It's a low-level, super easy, super convenient service. So there's no virtual machine host involved. It's just spinning up a container as a service. And the only thing it needs is the pointer to the container image file. From there, everything I tried to show you already in a little bit of the logging of the container, the interaction with a container, will still be available. Now, to make it a bit exciting, let's do a little time check. All good for now. Let's create a new container instance. It's almost like any other Azure resource you want to create. It needs a resource group, the aMS RG, container name, live demo, PDT, or anything else, not that important. My image is in West Europe, so probably it's the easiest if I deploy my container in West Europe as well. And from here, I need to identify, like, where can I find the container image? There's a couple of quick start images to test. The ACI Hello World is literally presenting Hello World in a browser, so nothing too fancy about it. And that's where I wanted to make it a bit more exciting and using a full-blown e-commerce example. We can integrate with Docker Hub or any other registry, public or private, as long as you do have the URL and the credentials, you're good to go. I'm going to use my container registry. So the internal simple ACR registry, and I already have a couple of images available there, and I'm going to use my Simple Commerce, the one I created out of my Visual Studio. I can decide the underlying platform. Now, since I identified in my Docker file that I'm going to run this container on top of Linux, it's obviously already recognizing it. Why? Because the container image somehow has information available, like what are the system dependencies. And then last, I can identify or specify the sizing for the container. So let's say my e-commerce platform comes up and I'm expecting like 500 connector users every hour. Then I probably need to allocate some larger CPU size, some more memory size. But for a demo, good to go with 2 CPUs and 2 gigs of RAM. From the network perspective, although it runs as a public cloud service, the default behavior would be public. So what it's going to do is create a public IP address for the container, at least for the lifetime of the container, as long as it's running. If I use containers for internal workloads that I don't want to expose to the public internet, I could move to private. You can add DNS host names if you want, and you could add container variables that you would typically pick up using Docker run, specifying some variables like connection strings, some other system settings, persistent disk volumes, and you could still do the same using the Azure Container Instance options. From here, it's creating my container instance, should take about a minute, reaching out to the container registry, copying over the image to the running instance, and starting up the container. So all this typically takes about a minute. It all depends on the region, depends on the size of the container image itself. And let's just give it a little bit more time. I hope you enjoy seeing live demos and not just some screenshots or some recorded demos. And I hope it's done within the promised minute. Otherwise, you go like, well, you promised something, but Azure is slow. It's probably not that slow. I need to be careful what I'm saying. I'm promising. I'll keep it running for a second. Perfectly cool. Now, what I did so far is, still a lot of manual actions, right? You need to do the Docker file creation. You need to compile the container image. From there, you need to create a registry. You need to create the image, pushing it out. So a lot of like manual steps where every now and then it could feel like you're losing the flexibility, the benefit, the speed of use in spinning up containers. And that's all that Azure ACI is giving you. So wouldn't it be cool if you could actually speed it up even more? So what happened a couple of months back, somewhere July, August timeframe, at the Docker conference, virtual conference, obviously out of COVID, but what they allowed is a direct integration between Docker as the command line service and directly connecting to Azure Container Instance in what they call a Docker context. So almost similar to what I showed you, Docker push, moving it into the registry, you don't have to do all that anymore. So you can directly move a container from your local machine, pushing it out into a running state in Azure Container Instance. There's a couple of steps involved. Now, I'm going to skip that part of the demo. If you're interested in seeing that, go to my website. It's www.007ffflearning.com and search for Docker deploy ACI. So it's a blog post from somewhere August. And if we do have some time at the end, I can pull up the link. There's a full description from deploying Docker desktop, how to enable it for Docker context, and using it with the exact same e-commerce example I'm showing you right now. Let's see how far the instance is. There we go. So my instance is running. There's some CPU memory load, so that proves that it's actually running. And there's a public IP address.
Hello.
Yeah, go ahead.
Peter, you are talking 1 hour alone because we want to interrupt you more than one time. It's not possible. We have no picture there. Hans speaking.
Okay.
So all the demos, we only see your PT and nothing else. And we interrupt you more than once, but you can't hear us. I have no idea why. And there is no screen available.
I had some technical glitches to get in first. I did screen sharing once the recording started, but apparently it's, I don't know, not good enough, or it somehow lost connection. Okay.
I only want to say, maybe you can try share your screen again if you see what happens.
Let's try. So it says, on my side, it says that screen share is still on.
Nope.
So you heard me talking without any
screen
imaging?
So 5 people were there, but sometimes, and that's no one is hearing, and I tried now again to show you. That makes no sense.
So I'll try screen sharing once more. And
that's a normal Teams, therefore. Yeah, now it's there.
Yeah, it's the exact same look and feel than what I had earlier.
I only want to say it because it makes, sometimes it's not so easy to understand why is the problem there. And as I'm doing a lot of trainings although, and sometimes I say, okay, I take another surface and put it as an attendee. But today it was a little bit horrible because in Teams live and Teams not live and do a normal meeting and so on. But we have to say excuse, but you don't have to talk to nobody because I'm jumping in from one session to another and see you are still talking to the nowhere. And that makes no sense.
Okay. No, but I would say don't worry too much about it. Now, if you want, I could still provide a recording of the session. if you want to upload it later on. I guess you present the recordings after the conference anyway.
Yes,
so
we do that.
I'll share you a recording. I already
Yes.
have all the demos from another session, so it's the same.
You can do and give them to Untitled thing or to Patrick, and I talk to Patrick and say it's okay.
Oh, okay. No, that's good. Yeah, it will probably be somewhere over the weekend then, if that's fine.
Perfect.
Okay. No, cool.
Okay.
Perfectly fine. My demos were working, so that's always fun. I would say thanks for interrupting,
yes.
and I'll make sure I send you the recording over the weekend. No worries there.
Thank you so much.
Thank you.